Good day, Dr. Zaki and my fellow friends. I, together with Siti Noor Aisha and Ashikin from Group 8, will be presenting on production of butylene from various pathways. The first one is by methanol to olefin to produce butylene. This process was first discovered in 1977. Methanol can be first produced from coal or natural gas. In this reaction, acidic zeolites act as catalysts. Their selectivity mainly depends on the temperature, as at low temperature, methanol reacts to form dimethyl ether. Only at high temperature, olefins such as butylene is produced. This is the process flow diagram for the production of butylene through MTO. First, methanol is fed at fluidized bed catalytic reactor at 350 degrees Celsius and 1.5 bar. The reactor effluent is then cooled and compressed to remove carbon dioxide and water. Further compression at high pressure are done to separate the products, which consist of ethylene, propylene and butylene.
Hi, I am Nurashikin. I will continue with production of butylene from butane by using dehydrogenation process. So dehydrogenation is the chemical reaction that involves the removal of hydrogen, usually from an organic molecule. It is useful way of converting alkene, which are relatively inert and those low value, to olefin, which are reactive and those more valuable. The figures show the dehydrogenation process unit in manufacturing plant. The dehydrogenation process plant located at China, Texas, and other location also. So this is the general mechanism for the dehydrogenation and hydrogenation process. For the dehydrogenation, H2 is eliminated from alkene to form an alkene. Next, this is the production of butylene from butane by using the hydrogenation process. So this is the chemical reactions of butane to form butylene, and the byproduct is hydrogen. So the catalyst that we use in this process is chromium potassium alumina catalyst, and the temperature is around 600 degrees Celsius. The picture show the block diagram of the dehydrogenation process. So the picture in the left side show the current dehydrogenation process. So from here we can see the dehydrogenations of ethane will produce ethylene, dehydrogenation of propane will produce propylene, and dehydrogenations of butane will produce butylene. In the right side is the proposed dehydrogenation process. Next, thermal steam cracking process. Thermal cracking is the process of breaking down large compound into small compound at high temperature. The temperature range between 500 to 700 degrees Celsius, used for visbreaking, breaking, thermal gasoline production and delayed cooking. Thermal steam cracking process do not use any catalyst in the process. Higher reaction conditions compared to catalytic cracker, and the figures show the steam crackers at Germany. The whole site is the largest continuous chemical site in the world. Next, Ration equations of thermal steam cracking process. So from propane to butylene, we consider two processes, which are thermal steam cracking process and also polymerizing process. So for the first reaction is the propane to ethylene by using a thermal steam cracking process at pressure, atmospheric pressure and temperature around 625 to 850 degrees Celsius, and no catalyst. The second reaction is ethylene to butylene by using a polymerizing ethylene process at pressure 1 to 10 atm and the temperature below 150 degrees Celsius, and use catalyst cobalt charcoal.
Assalamualaikum warahmatullahi wabarakatuh and very good afternoon. So I'm Siti Aisha binti Ismail. We'll continue the presentation on the production of butylene from crude oil. Basically, the process involved is fluid catalytic cracking, or known as FCC. It is used to convert high boiling point gas oil to high value octane gasoline and heating oil. Besides also has been proved to be more efficient compared to the thermal cracking. Okay, moving on to the next part, that is a chemical reaction. Basically, it involves in long chain alkane to produce smaller chain alkane by fractional distillation and further react to produce butylene from FCC process. The process involved in high temperature and low pressure. It also uses zeolite-based catalyst in form of fine powder, which provide good stability, high selectivity and yield, and low coke formation. According to the study from Froment and Biscoff, there is no such reaction mechanism for this process, even though the catalysts used have remained almost unchanged for several years. So this process are still under study. However, it involves three main reaction groups, that is primary reaction, hydride transfer and coke formation. Okay, so among these four processes, currently the MTO and FCC process have been commonly used in industry due to its advantages of the process. Both of these processes involve in high temperature and low pressure condition, as well as it use the same catalyst medium character. So, additionally, the BASF recently announced the availability of the new FCCU additive product designed to enhance the production of butylene in order to address the global demand, which is expected to favor clean and low sulfur fuels. Thank you.